recording voice too?
Yeah.
Okay. Alrighty, that's 8.5 millibytes already. Holy moly. Get rid of this shit real quick. Just talk and do shit?
Yeah.
Alright.
Recording.
Alrighty, take two. This is a vector. A vector. No, we don't want that yet. Hold on, let's start over. Not yet. Alright, take two. Take three.
Take
three. Okay. This is a vector. A vector is just an arrow. In physics, vectors are important because they represent magnitude and direction. So, let's take a look here. For example, the magnitude of vector A is 15. The units don't matter right now, but vectors can represent a bunch of different things in physics, which is why they're important. Anything that has magnitude and direction. So this vector could be about force, so this could be in newtons. It could be about velocity, so this would be distance over time. It could be about acceleration, so it could be velocity over time. All sorts of things it's useful for. Working with vectors, we can find a lot of these values using SOHCAHTOA and basic trig like Pythagorean theorem. So for example, we have our opposite and adjacent and our hypotenuse. These two pieces of the vector, the x component and the y component, are important because they can be used to summarize the vector. We can do what's called IJK notation. So it would be, for example, vector A is 15i because that's the x component, or 10y because that's the j component. That's another way of notating it. Here's another way of looking at it. Same thing, x, y. Same thing, looks weird, but it's still just x and y. And let's do a more complicated example. We could do a vector like this, and then a vector like this. Now when we have weird angles like this, we can use the components to add them together and figure out what the sum is. So for example, the x for this sum vector that goes between them from the beginning to the end, like that. The sum for the x components would just be the x component for this guy and the x component for this guy added together. And then the y components would be this guy and this guy added together to get the sum. Get rid of that somehow, I don't know. We could also do more arrows like this. Fun fact, if the vectors come together and make like a polygon like this, it means that added together the vector sum is 0 because it's ending up where it started off, so the total change is nothing. So for these two blue arrows, the sum takes us to the end of the blue, and then for the sum of the orange, it takes us back here, so the sum is 0. And did I miss anything? No? And I think that's it. Vectors are simple once you understand what they stand for.